Hi everybody. We're going to work with one more form of factoring polynomials here, and this form is called factoring by grouping. Now, this method we can apply only when we're working with polynomials that have four terms. So if we take a look at the example here, we have RA plus RB plus SA plus SB. The grouping part of this method means that we're going to chunk this guy together in groups of two. So we're going to look at the first two terms as one piece and the second two terms as one piece. Now if we look at RA plus RB here, both of these terms share an R, so we can factor that R out to get R times A plus B. When we look at the second chunk of terms here, SA plus SB, both of those share an S, so we can factor the S out to get S times A plus B. Now, because both of the terms here in blue, A plus B and A plus B, are exactly the same, we're going to kind of use the reverse distributive property here. So we can take whatever term is in front of both of these, in red here, the R and the S, and we can group those two terms together inside one set of parentheses, giving us R plus S in one set of parentheses and A plus B in another set of parentheses. Now, if we actually apply the distributive property here and FOIL this guy out, what are we left with? We're left with R times A, which gives us RA. R times B gives us RB. S times A gives us SA. And S times B gives us SB, which is exactly the original expression that we started with. Now, when we apply this method to polynomials, let's take a look at this one down here. X cubed minus 3x squared minus 16x plus 48. We have four monomials in this polynomial, so we're just going to group the first two together and group the second two together and try to factor down each grouping of parentheses individually. X cubed minus 3x cubed, we can factor out an x squared out of both of those, leaving us with x minus 3. We bring down our minus sign. And in the next set of parentheses, we can factor a 16 out of both of these terms. So we factor out the 16, and we're left with x minus 3. Negative 16 times x gives us negative 16x. Negative 16 times negative 3 gives us the positive 48. Now, if we take a look at what we just did, we have x minus 3 and x minus 3. So we have the same binomial and two different things in front of that binomial. We have an x squared in front of this one and a negative 16 in front of the second one. So we can group the x squared with the negative 16 inside one set of parentheses to get x squared minus 16 times x minus 3. Now, can we factor this down any further? Yes, we can. X squared minus 16 is the difference of two squares. So when we factor down x squared minus 16, we're left with x plus 4 times x minus 4, and the x minus 3 comes along for the ride. So this is our completely factored version of our original polynomial. Let's run through one more problem for practice. So our polynomial here is x cubed plus 2x squared plus 3x plus 6. We want to factor this by grouping. So we're going to group our first two terms together and group our second two terms together. Now when we look at these individually, x cubed plus 2x squared, what do both of those terms have in common? An x squared. So once we factor out an x squared, we're left with x plus 2. The plus sign here comes down, and in our second expression here, 3x plus 6, both of those terms share a 3, so we can factor a 3 out, and inside the parentheses we're left with x plus 2. Now we have two binomials that are the same, x plus 2 and x plus 2, so we can group the x squared and the 3 together inside a set of parentheses, leaving us with x squared plus 3 times x plus 2. Now always ask yourself, is this as factored as we get? Can we factor x squared plus 3 down any further? No. So this is our final answer, fully factored. Let's run through one more for good measure. So here's our polynomial, 9m cubed plus 18m squared minus 4m minus 8. Let's group the first two together, group the second two together, and see what we can do. In our first term here, we have 9m cubed plus 18m squared. We can factor a 9 out. 9 and 18 both share a common factor of 9. And m cubed and m squared share an m squared. So altogether we can factor out a 9m squared. What are we left with inside the parentheses? We have an m plus 2. Minus sign comes down. What can we factor out of our second term here? 4m minus 8. 4 and 8 share a common factor of 4. M is just in the first term, so that's going to stay where it is. So it looks like we could just factor a 4 out of this one. What are we left with inside the parentheses? M plus 2. Now let's double check this to make sure everything's good in the second one. Negative 4 times m gives us negative 4m. Negative 4 times positive 2 gives us the negative 8. So this is all set. So now we have m plus 2, m plus 2. So we can group our 9m squared together with our negative 4 and rewrite this as 9m squared minus 4 times m plus 2. Can we factor this any further? 9m squared minus 4 looks like the difference of two squares. So we can factor the first term down into 3m plus 2 times 3m minus 2, and the m plus 2 comes along for the ride again, and this is fully factored. Here's a couple problems for you guys to try for homework. Remember, the key here is to group the first two terms and the last two terms together and try to factor each of those sets of parentheses individually. Once you have your common factor in both, you can group the term that's in front of both of your common terms together, and then make sure that your answer is fully factored after that point. Good luck.